Hello, our most developed student. My name is Confident and welcome to our session here where I'm going to look at the application of calculus. And this is the part where you look at the rates of change, and this question usually follows after the normal cubic function. So when you're doing your exams, after you see question, it can be a different question number, of course, but the moment you do your normal cubic graphs, after that particular question, the next question you must expect is the application questions. So this is where you expect the application of calculus. So this is one example that I'm going to do in this video. And another one again, look at this, is this paper. I think it's a prelim paper. It was a cubic function question. And then after that, there was an application of calculus. You see, question number 10 in this case. So I'm going to be looking at these two questions. This was 8 marks. So we're going to look at this, and most of the time they'll say, for example, calculate the maximum area of the picture TUV. The maximum. That's where your focus is. Look, the maximum area. You go back to this other question here. It says calculate the value of X for which the flow will be a maximum. So these are the kind of questions that you are expecting when you are dealing with the application of calculus. So it's more like a practical example. So let's look at this question here. Question number 10. Let me make it a little bit bigger. What is it saying? It says here, a certain high school wants to build a stage as shown in the diagram below. So this is more like a stage. And then says this stage floor consists of a square, which is CEF. You can see the square here. In other words, they're talking about this as the square here. So we got our square there. All right, and then two congruent. The word congruent means, remember, identical. Two congruent triangles, and then we've got what? ABF. You can see ABF as well as DCE, because these are congruent triangles. If I can use something different, you can see that they're talking of those two triangles. All right, as they're saying that, but they just don't want to spend time here, but you can see what they're talking about. And then it says each side of a square is y units. You can see that the length of the hypotenuse of the congruent triangle is what? 8 units, and then AB is equal to CD equals to X. So AB, there is the X part and there is the X part, and then angle A is equal to angle D, which is 30 degrees. The first things first. What are they saying here? They are saying show that the area of the stage floor can be written as this. So they want us to show that the area, we are proving that area. So now if you have to look at this picture here, to find the total area here, the simple part first of all is to look at the square. Remember, what is the area of the square here? I will say, if I'm to write here, to say area of square. What is the square? Area of square. They told us the square is BC EF. Remember, is what? It's y times y, which is equal to y times y, which is equal to what? Y squared. So here the area is equal to y squared. All right, and then what about the area now of these triangles, these two triangles? Now the hint here is to look at what they gave us here. You see, they gave us in terms of sin 30, which means if I'm to redraw this kind of shape, but I want to twist this, if I can actually take this guy here, let me see if it's possible. If I can take this guy and copy it and bring it to this side. Okay, it was possible but not fully possible. Now let me complete that. So let's say I had this. Remember, it was what? It was A and B and what? F. And then this angle here is what? Is 30. Are you with me? And then you've got your 8 here, and I've got my y here. So now if I have this one and kind of, let me do this again. I kind of, let me see, yes, it's possible. I rotate this like this. That's what I just wanted to do. You know, everything is still maintained the same here. I just rotated it. So if I manage to rotate it, now remember, when you're finding the area of a what? Of a triangle. Let me again bring some bit of knowledge here. If I've got a triangle like this, we got a triangle, and we're gonna call this triangle ABC, right? And we want to find the area now of this triangle. Remember, it says area is equal to half. Now if it's not a right angle triangle, you're going to use half AB sine C. There is this formula, but how does it go about? Now if they say A, it means there is the smaller a there, that is opposite, and then B, it means there is the side B here. I think that, and then C is that angle. Now look at this. Let me remove the inside here. That's not what I want. Look at this now. When you're finding the area of a triangle, you are saying half, which is half base times height, remember? And then look at the sides. You're going to say that side, which is your A, side A in terms is BC, and that particular side, which is your AC, but denoted as small b. But the angle formed by those two sides, you see, they form that angle. Are you seeing that? So I can change this and say, what if I was dealing with this side and this side? Now we're talking about blue. So look at the area. I'm gonna write, it's gonna be area is equal to half, right? Now since I'm dealing with this side here, this particular side is small c and this side is a, so it will be a c sin what? What is that angle? It's from angle B, sin B. Are you seeing what's happening? It doesn't matter. It doesn't matter which side to choose. Let's say I choose, for example, here, I choose this side with the purple, and I choose this side. Now look what I have. The two sides here at this stage are what? Are C and B. You see that? So my area will be equal to half. My two sides is BC. Now look at the angle that I've formed by those two lines. They form angle A. So you say sin A. Are you seeing that? So with this whole concept that I'm doing here, it is the same thing that I'm going to apply here to say, if I'm to find the area of this particular shape, look at it now. I've got here that line and I've got that line. You see that? So in this case, if the area, it will be area of triangle is equal to half. Now this side is AB. See, it's AB times AF sin what? There is the angle there, sin 30. You see that? I didn't want to take time, but that's what I wanted to bring across, which is half. Now AB, let me check, did they give us AB? Yes, they told us it's X, so AB here is X. See, so half X, and then AF is 8, X times 8 sin 30. Are you getting that? That is what you're having there. So we are gonna leave that for now. But they told us these triangles are congruent. There is this side and there's this side. So you've got two sides here. We've got this one and we've got that one. So which means the total area is that and that times. So it's this one plus this one. So in other ways, it's twice. So you're going to say area of two triangles here. Therefore, area of two triangles is equal to 2 times half times, let's say x times 8, which is 8x sin 30. Are you seeing that? Then that's why you can cancel that now. Half times 2, then you've got 8x sin 30. Are you seeing that? Then from there, look what you have. There it is 8x sin 30. But now where is this 64 minus x squared? So now remember, we said the area of the square is y squared, and there is no y here. You see, they didn't write it in terms of y, meaning we can find out y in terms of what? In terms of x. But now, how do we go about it? So we are saying the area of square is equal to y squared, right? But now something important here. Look at the same triangle here. We can use the same triangle, and this particular triangle, if you look at it, it is, look at this, it says a floor consists of what? A floor consists of a square. So if this is a square, automatically we know that that angle is 90 degrees. So here it's 90 degrees, meaning I can have then the theorem of Pythagoras. So this is more like a right angle, you see. So now remember the theorem of Pythagoras. What does it say? Is the longest side AF squared. Here I can say Pythagoras. What does it say? It's AF squared is equal to, and then I've got AB squared plus FB squared. So it's AB squared plus FB squared. So what is AF squared, which was what? 8 squared is x squared plus y squared. I think that. So 8 squared is equal to, I hope that was x squared, and then the other one was y squared, but you can interchange whatsoever. Now remember, I don't have y, so how can I make y the subject here? So what I do, I take x this side, so it will be 8 squared is 64. Let me just write that. 64, now sorry, that becomes negative x squared is equal to y squared. See, so I've got the value of y. So now when I'm to find the total area is equal to, now we are adding then the area of the two triangles, which is this, and what? And the area of the square, which is that. Are you getting what I'm saying? So that is the total area. We are adding that part, you add this one, that one, and that one. So already we got these by 2 and then plus y squared. I think that. So which means when you add, this is the total area now. We are going to add that, but we know our y squared. So it's y squared. Let me maintain that. It's y squared plus 8x sin 30. See, that is the total area. But what is your y squared? This is our y squared, you see, which is equal to 64 minus x squared plus 8x what? Sin 30. I agree with me. If you take this now and compare the answer, there it is. We can now write it the way they want it. Is 8x plus sin 30. We can start with that, which is 8x sin 30, not plus sin 30, it's just 8x sin 30, and then plus 64 minus x squared. There it is. And then it says show that. Then you can say this has been what? Shown. Alright, then the next thing is, the good part about these questions sometimes is they give you the final answer, and then even if you can't, even if you're struggling to make it, it helps you to move to the next question, because the next question, in a way, you can use, even let's say you fail to prove this, you can just move on and say, okay, I failed to prove this, but I'm interested in this word maximum. When you see that word maximum, that's where you remember application of calculus. Don't forget that. That is simple dy over dx. So let's take it now and say, remember they are saying what? You can actually use it here. Let's work it out here. They are saying to me a is equal to 8x sin 30. So that's why I'm saying you didn't need to go to the they say you struggled coming out with this answer. You could have just continued now. When they say maximum, now this is not y. You just use now, instead of saying dy over dx, you use the variables dA over dx. Whatever is on the left and on the right, the left becomes on top, the right variable becomes at the bottom, is equal to, when you differentiate, remember, whenever you're differentiating, where there is a multiplication is treated as one thing. So here you treat this thing as one thing here, and then plus, and then you treat that as another separate thing, minus, you treat that as another separate thing. Or I can say minus, I treat that as a separate thing. So the signs are separating. So let's start with the first one, the second one, and the third one. Let's apply the rules. Now, if you differentiate anything to do with x, for example, if I say y is equal to 2x, now dy over dx is simply equal to what? 2, because that becomes 2 times 1. The x symbol becomes a 1. Alright, so that's what is the same here. When I'm going to differentiate, on this case, 8x, it will be 8 bracket 1 sin what? Sin 30. That's the first one. Plus 64 is just a number. There is no x there. When I differentiate 64, it becomes 0. And then minus, when you differentiate x squared, remember you drop the 2, and then you're saying x2 minus 1. I'm applying the rules of calculus. So now here, sin 30, you definitely need now to find out what is sine 30 there. And then let's use our calculator then. So if I say sin 30, it gives me half. So here I've got 8 times 1 over 2 minus 2x. 2 minus 1 is x. So it continues 8 times half, then you've got 4 there. So it's 4 minus 2x. So look at this. Here you are saying dA, change in a over change in x. So dA over dx is that. But now, remember they said maximum. When they say maximum, you are back again to the maximum and minimum. You must know here f prime and back f prime x at maximum is equal to what? 0. So that's what you do here to say, you state here to say add max dA over dx is equal to 0. Then you conclude, say therefore 4 minus 2x is equal to 0. Of course, you take 2x already since it's negative that side. 4 is equal to 2x. You divide by 2 on both sides. What you have, that is x is equal to what? X is equal to 2. This becomes the answer, and the question here was what? Calculate the value of x for which the area of the floor will be maximum. That's the answer there. Or sometimes they would have said, what is the maximum area? If they ask you what is the maximum area, that's where you come here, where there is x, you put what? You put your 2, you put your what? You put your 2. Then you will find the maximum area. But here they just wanted the value of x. If they wanted the actual area, you're going to take that value and put it here, plug it there. It was going to give you the maximum area. Alright, so that's the first part. Let's look at the second one. Remember I told you these questions follow what? The cubic functions or the cubic graphs. So they ask you a question, you work it out. I've done these questions, by the way. Check out in my previous lessons, look for them. I did these questions, so you focus on this. Even this question I did it, this one I did this question. You just have to check the previous videos. This question has been done. So after this question, when you're done, you focus, you follow up on what? On the rates. That's the application. It goes to question 10. Again, question 9, you see this was a previous paper there for the prelim, and then after that, next one is what? It's a calculus problem. Look at this one. It says in the diagram below, TUVW is a rectangular picture. The picture is framed such that there is a 3 centimeter space around the picture. The perimeter of the rectangle PQRS, PQRS is 70 centimeters. Perimeter PQ is equal to X units and QR is equal to Y units. So they gave us this, and then calculate the maximum area of the picture TUVW. Now let's work a little bit here. They are telling us a few things that you need to be aware of. So if I can just cut these things like this, it will help a lot. We cut it here, we cut it here, and then we also cut it there, we cut it there. It will kind of make sense. Let me just do this and then it will make sense. Now, why am I doing this? Why am I doing this? I'm trying to find, let me just use a thicker liner. I'm simply trying to find, let me use this, I'm simply trying to find this. You see, that's the area. That's all that we're interested in. We want to find the area of that. You see, whatever the face is inside. Now, to find the area, you can see that this is a what? This is simple a rectangle. So, if you can literally write area of what? Says TUVW. So, if I can write it here and say area of TUWV is equal to length times breadth. Right, that's all that we need. Remember, it's a rectangle, so it's length times breadth. Now, what is the length? The question is, what is the length? What is the breadth? That's all that we're trying to find. That's the first part called, but now later we are going to use that word maximum. For now, we want to find the area. Simple things. Now look at this. You know that here they told us that there is this 3 centimeters, meaning there is 3 between this side and that side. See, even here, this side and this side is what? Is 3 centimeters. Alright, because they did mention, says the area, the picture frame is framed such that there is a 3 centimeter space around the picture. Alright, so even here, when you look at this distance here, like here, this distance is 3 centimeters, 3. So even here, that distance is 3. So what does it simple mean? It simple mean already 3 plus 3 gives me 6. So this length here is equal to the total x minus the first 3 minus the second 3. So if you are going to say minus 3 minus 3, it's as good as saying what? Equal to x minus 6 here. I saying that it's x minus 3 minus 3 is minus 6. That is the length. You do the same thing with the breadth. The breadth is what? Is y, because they told us this distance here was x also, remember. So it is y minus 3 minus 3, same as what? Y minus 6. Are you with me? So I can come here now. I know the length is x minus 6, the breadth is y minus 6. So I can write the formula there and saying length times breadth, which is what did I say? Length is x minus 6, y is y minus 6. So it's x minus 6 times y minus 6. That's the area there that they are looking for. But there is there anything that they need? They gave us a hint. Yes, the perimeter of the rectangle PQRS is 70 centimeters. Do you know why they gave you this statement? They gave you this statement because, look at this. If I'm going to open this bracket, the moment I open this bracket, I will have x and y. Now, the aim of this whole question, if they say calculate the maximum area, now remember you'll have area is equal to, so you'll have whatever you have here, and your maximum, remember it's calculus f prime x, whatever you're dealing with. So in this case, area will be dA over, now since already we have x, we're going to call it dA over dx equal to, so which means if our area, let me go down here, if our area, I mean dA over maximum here, we're going to say maximum area will be equal to dA over dx is equal to, it means everything here must have only x. I cannot deal with that particular y. I think that, hence they gave me the perimeter. That's why they gave you the perimeter. So now you must understand what does the word perimeter means. Perimeter means the distance right around the shape. So here, sorry about that, here on this shape, when they talk about perimeter, is the distance right around this shape. So they told us the perimeter of the rectangle, the bigger rectangle. So if I add this particular x here plus x, so it's x plus x is 2x, and then y plus y, the bigger side. They're talking about this big side. It's y plus y, which is 2y, x plus x. I sing that. So the distance right around this big shape. So it will be what? X plus y is equal to x plus y plus y, which is what? 2x plus what? 2y. But they told us the perimeter. Perimeter is what? Is 70. Okay, so that's what is the whole thing. Let me take this thing down because we're going to use it later. Now 70 here is equal to 2x plus 2y. I can factorize 2 there, which is x plus what? Plus y. You see, I divide by 2 on both sides. That's where the whole thing was. So I've got now my x plus y. 2 divided by 70 is 35. That is what was needed. I'll call this my equation 1. That's the main thing. So that first equation, or equation 2, let's call it actually equation 2 here. And then this one, area is equal to length. We'll call this one maybe equation 1 because that's where we started. Look at this. I know now from my equation 2, I've got 35 is x plus y, which means I can make y the subject. Take x to the other side. It will be 35 minus x is equal to what? Is equal to y. I think that this can be my equation 3. Then I'm going to take, I come back here, I'll work it on top. I will say from here now, it's equation 3 into equation 1. So what is it? Remember, area is equal to what? X minus 6. And then they say y minus 6, but I know what is my y. Now what is my y? My y is 35 minus x, you see. So my y here is 35 minus x, but it's minus 6. Don't forget the minus 6 there. Alright, so my area is x minus 6, and then what is the other one? 35 minus 6, I think it's 29 minus x. That is the area in terms of x. Look now, this is in terms of x, meaning it's only x now. You no longer have y. That's your area. At this stage, it's easy for me now to find dA over dx. Do you see where the whole thing was? I can now apply this part now. Why? Because I know the area. So let's apply it. Let's first find this. Let's open up this bracket here. Look at this now. We are saying A is equal to, let's open x times this. It's 29x. We are opening, remember FOIL, we are opening this bracket. X times that is negative x squared. And then negative 6 times that is negative 6 times 29. We're going to find the answer there. And then negative 6 times that, it's positive 6x. Are you with me? So area is equal to 29x. Bring things together, plus 6x minus x squared minus what? What is 6 times 29 actually? 6 times 29, 6 times 29 equal to what? 174 minus 174. Even here, I can actually, okay, let me write the next stage. A is equal to 29 plus 6. 9 plus this is 5. So this is 35x. Alright. Minus x squared minus 174. Remember, where am I going? dA over dx. So here I come back and say at maximum area. Remember the question was what? Let's go back to the question. Says this: calculate the maximum area of the picture. So at maximum area, you count now to say dA over what? dx is equal to 0. Now let's find dA over dx. What is dA over dx? dA over dx is equal to, then let's do that. Now remember I said when you have got x there for 35, it simply becomes 1. So you say 35 times 1 minus, for the other one, x squared, you drop the 2, it's x, 2 minus 1, right? Let me do this. x2 minus 1, these are the rules of differentiation. Minus what? 174 is a number, it becomes simple as 0. So this becomes what? 35 minus 2x. But we did mention that at the maximum this is equal to 0. Therefore 35 minus 2x is equal to 0. Take already x is negative, so it's 35 is equal to 2x. You're solving for x now. You divide by 2, you divide by 2. Guess what? There is the answer. 35 over 2 is equal to x. Now the question says what? Be careful now. Calculate the maximum area. They didn't say find the value of x like the previous question. This one wants the maximum area. And you know what is the maximum area? This is the area here. Remember? So if you take the value of x at maximum, now let me remind you, this is the value of x at max, right? Because you find dy over dx. So you're going to take this value and you go and plug it in up there. That's what you're gonna do. You take this value of x and you plug it in up there. So you're going to say therefore maximum area here, therefore maximum area here is equal to, so you can write A max is equal to 35. Are you seeing that? There are two ways you can use that one. Where there is x, what do you put now? 35 over 2. See? So you can say x 35 over 2 and then minus x squared, which is 35 over 2 squared minus 174. That is one way. Or you can say A max is equal to, use that one that was simpler. Let me just erase this. There is the one where it was 2 brackets. It was x minus what? There it is, x minus 6. I think not this one, just that there. X minus 6, y minus 6. Remember this one. We can use actually this one. X minus 6, y minus 6. I think that. Now, which is x minus 6, y minus 6. But now we know what is x. X is 35 over 2 minus 6. But now you need to find the value of what? Of y. You come here, maybe to do a little bit of working now. You know the value of x here is equal to what? 35 over 2. So the question is, once you know the value of x being 35 over 2, what is the value of y? You understand here? So remember what we said on the perimeter. We said this was the equation here. Perimeter 35 minus x. So you know the value of x here. You can take this further and say here 35 minus 35, which is your x, over 2 is equal to y. You see? So it can give us y, which is equal to what? Let's just use a calculator there, which is 35 minus 35 over 2. It gives us 35 over 2. Actually y is also 35 over 2. Oh, okay, that is that. So we come here and say for y here, which is 35 over 2 minus 6. Okay, so it was it more like a square here? It's more like looking like kind of a square in some sort. All right, but anyway, it's fine. Let's look at these two answers. If I use the calculator and see whether I'm getting the same answer. So let's start with the first one. Is 35 bracket 35 over 2. All right, and then what do I have? Minus, okay, close there, minus, and then you've got what? 35 over 2 squared. minus 174. Alright, there is 529. It's 132.25. So remember this answer. Let's try the other one. Here is 35 over 2 minus 6. Okay, and then again 35 over 2 minus 6. It was actually square there. It's 132. Let's see if it gives us 132.25. There it is, 132.25, 25. Then remember, area, it's units squared. You can leave it like that, as units squared, u squared, meaning unit squared. Is the same answer here also, that we get is 132.25 units squared. We don't know the units, any units whatsoever. So this is how guys will approach such questions. And 8 marks. I know it looks like, well, you know, you might choose, I don't want to do such questions, but listen, it can work out for you. You need those 8 marks. That's your distinction, and it's simple. Uses calculus at the end, and more importantly, you can actually work your way around. Guys, we've come to the end of our lesson. Remember, as I'm preparing you for your final exams, don't leave out without subscribing, because it helps you to always follow up on the lessons that we're bringing here. We've come to the end of our lesson. This is the 24-minute lesson. It is the lesson that has you in mind. And remember, it's for the underdogs. Someone says, I'm struggling with my mathematics. I don't want you to hurry me. Take me slowly through the process and help me understand the concept. So that's why all our lessons, you find that they are 24 minutes or so. If they are above 24 minutes, make sure that you practice them in those 24 minutes pockets, because it takes you almost around 24 minutes to get maximum attention. After that, most of the time you're distracted. We've come to the end of our lesson. Thank you.